Hello everyone, welcome to Science Solutions with Karishma. This is the part 2 of the video Rational and Irrational Numbers chapter from the Concise Selina Mathematics of Class 9, and in this video we are going to solve questions from exercise 1A starting from question number 5, as I've already solved the other questions from this chapter in my previous video, so please go and check it. So this is the question number 5 of the exercise 1A. Without doing any actual division, find which of the following rational numbers have terminating decimal representation. So in this question, we have to find answer without doing any actual division. So what we have to find is whether these numbers have terminating decimal or not. For that, you need to keep in mind one concept. If a by b is a fraction and b, the denominator, is in the form or can be represented in the form 2 into 5 or 2 to the power m and 5 to the power n, m and n can be any number. So if it is in the form 5 into 2 or 2 into 5, then it is terminating. But if the denominator is in the form 2 into 7, 3 into 5 or any other number, it is not terminating. So let's do the first number, 7 by 16. The denominator is 16 and can be represented as 2 2s are 4, 4 2s are 8 and 8 2s are 16. Here you can see that there are 4 2s, 1, 2, 3, 4. So you can write as 2 to the power 4. Now we got 2 to the power m. And can it be written as 2 into 5? Yes, we can do by doing 5 to the power 0. Because anything to the power 0 is 1. Like 6 to the power 0, 1. And anything to the power 0 is 1. So if we multiply by 5 to the power 0, the value will be 2 to the power 4 only. And it can be represented in the form 2 to the power m and 5 to the power n. That is, 7 by 16 has terminating decimal, or it is convertible into terminating decimal. Because in the denominator, the number is in the form 2 into 5 or 2 to the power m into 5 to the power n. So by the same method, we can solve the other questions also. So let's do the next question, question number 2. It is 23 by 125. So in the denominator, the number is 125 and we can write 125 as 5 5s are 25. 25 into 5 is 125. So you can see there are 3 5s. So 1 plus 1 plus 1 will be 3. So it is 5 cubed. It is in the form 5 to the power n. Now we have to make 2 to the power m by doing 2 to the power 0 is 1. So 5 to the power 3 means 5 to the power n and 2 to the power m. So yes, it can be represented in the form 2 into 5 or 5 into 2 or 5 to the power n into 2 to the power m. So yes, 23 by 125 is or can be convertible into terminating decimal. So the next question is question number 3. It is 9 by 14. By the same method, we'll solve it. See, the denominator is 14 and it can be written as 2 7s are 14. Here we got 2 to the power m, but we did not get 5 to the power n. So no, it cannot be represented in the form of terminating decimal. Therefore, 9 by 14 is not convertible into terminating decimal. Next one, question number 4, 32 by 45. In the denominator, it is 45. So it can be written as 3 into 3 into 5. 3 3 is a 9, 9 5 is a 45. There are 2 3 and 1 5. We got 5 to the power n, but we did not get 2 to the power m, or we did not get 2. So it cannot be represented in the form 2 to the power n into 5 to the power n. So it cannot be represented in the form of terminating decimal. So it is not convertible. Next, question number 5 is 43 by 50. Denominator 50 can be written as 2 5s are 10 and 10 5s are 50. Here you can see there are 1, 2, 2 to the power 1 into 2 5s, 5 to the power 2. So yes, it can be represented in the form 2 to the power m and 5 to the power n. So yes, it has a terminating decimal. That means the denominator 50 can be represented in the form 2 to the power m and 5 to the power n. So yes, it can be convertible into terminating decimal. Next, question number 6. It is 17 by 40. Denominator 40 can be written as 2 to the 4, 4 to the 8, 8 5s are 40. Here we got 3 2, 2 to the power 3 into 1 5, 5 to the power 1. So yes, it can be written in the form 2 to the power m and 5 to the power n. So yes, it can be convertible into terminating decimal. Next question, question number 7. 61 by 75. It can be written as 3 5s are 15, 15 5s are 75. Here we got 3 to the power 1 and 5 to the power 2. We got 5 to the power n, but we did not get 2 to the power m. So 75 cannot be represented in the form of terminating decimals, as it cannot be represented in the form 2 to the power m into 5 to the power n. So 61 by 75 does not have a terminating decimal. Next, last question, question number 8. In the denominator, it is 250. So it can be written as 2 5s are 10, 10 5s are 50, 50 into 5 is 250. And here we got 2 to the power 1 and 5 to the power 3. So yes, it can be represented in the form 2 to the power m into 5 to the power n. So that means 250 can be convertible. It is convertible into 2 into 5. So yes, 123 by 250 has terminating decimals. So that was all in exercise 1A. Now we are going to do exercise 1B question. State whether the following numbers are rational or not. Question number 1. It is 2 plus root 2 whole square. So see this question properly. It is in the form a plus b whole square. So it is a square plus b square plus 2ab. So we can write it as a here is 2 and b is root 2. So a square 2 square plus b square root 2 square plus 2 into a is 2 and b is root 2. So it is in the form a square plus b square plus 2ab. 2 square is 4. Root 2 whole square is root 2 into root 2. So when we multiply two roots, root will be cancelled and it will remain only 2. Or you can say that the 2 will cancel the root and the remaining will be number inside the root, that is 2. So here your answer will be 2 plus 2 2s are 4 into root 2. So 4 plus 2 is 6 plus 4 root 2. So is it rational or irrational? So whenever you see the root, they are always irrational. So it is not a rational number, it is a irrational number. Next, question number 2. 3 minus root 3 whole square. So it is also in the form a minus b whole square. It is a square plus b square minus 2ab. So the formula is a minus b whole square. So here a is 3, so 3 square plus b is root 3, so the root 3 square minus 2 into a is 3 and b is root 3, so 3 into root 3. So we get here 3 into 3 is 9 plus 2 will cancel the root, so it will be 3 only, minus 2 3s are 6 root 3. 9 plus 3 is 12 minus 6 root 3. So here again we got the root, so it is not a rational number, it is irrational. You can also write this as 6 taking common, you'll get 2 minus root 3. Root 3 is irrational, so it is a irrational number, not rational. Next question, question number 3. We have 5 plus root 5 into 5 minus root 5. So see this question properly. It is in the form a plus b into a minus b. A plus b into a minus b. A here is 5 and b here is root 5. So it is a square minus b square. So we can write it as here a is 5 and b is root 5. So 5 square minus root 5 square. A square minus b square. So 5 square is 5 5s are 25 minus 2 will cancel the root, you will get 5. So 25 minus 5 is 20. So yes, it is a rational number. Next, question number 4. Root 3 minus root 2 whole square. Root 3 minus root 2 whole square. It is in the form a minus b whole square. The formula is a square plus b square minus 2ab. So here a is root 3, b is root 2. We can write root 3 square a square plus b square means root 2 square minus 2 into a is root 3 into b is root 2. So we get here 2 will cancel the root, 3 plus 2 will cancel the root, 2 minus, we have to multiply the number, 2 1s are 2 and 3 2s are 6 root over 6. So 3 plus 2 5 minus 2 root 6. Again we got the root, so it is irrational number, not a rational number. Next we have question number 5. It is 3 upon 2 root 2 whole square. So directly you have to square it. So this 2 is for 3 also and 2 root 2 also. So we can do it as 3 square upon 2 root 2 square. So 3 square is 9 and 2 square is 2 into 2, 4. And root 2 square is again 2 will cancel the root and you'll have 2. So 4 into 2. So we got the answer 9 by 8. So yes, it is a rational number. Next, it's question number 6. Root over 7 upon 6 root 2 whole square. So you have to square root 7 and 6 root 2. Root 7 whole square upon 6 root 2, 6 square into root 2 whole square. So we get 7 here and 6 6 are 36 into 2 will cancel the root into 2. So 7 upon 36 into 2 is 72. So yes, it is also a rational number. So that's all in this video. In the next video, that is in the part 3, we are going to solve the other half of the exercise 1B of the rational and irrational chapter.